Hey guys, so today in this video we are going to solve the October-November 2020 paper of 5054, which is O-level physics of 2020. Okay, so let's start. So this is an MCQ paper where there are multiple choice questions, so we need to choose one out of the 4 possible options. So let's see the first question. A heavy nail is fixed firmly to a wall. It is pulled by a string at 40 degrees to the vertical. The nail does not move. Okay, so this is a very important thing. It says that the nail is not moving. This means that the nail does not move. So here they have mentioned the forces on the nail, its weight, which is W, its tension T on the string, and force R, which is exerted by the wall. Okay, so it says which diagram drawn to scale represents these 3 forces. So one thing we need to understand, since the nail does not move means that it's at rest, or it cannot be moved by any of these forces. So this means that the resultant force on the nail is equal to 0. So whenever we need to understand, this is a very key concept, whenever the resultant force equals 0, we are actually going to get a closed polygon. By a closed polygon we mean that if we draw a triangle or any other polygon, if these are the directions, they are all going to be head to tail, like this. So this head ends here, this tail starts, this head ends here, this tail starts, and again. So all of this head to tail will join together to give a figure like this, where every arrow will be head to tail, and this will be a completely enclosed figure. So normally whenever there is a resultant force, if these 2 arrows we give like this, then this resultant force arrow will be in the opposite direction compared to the other 2, which shows there is a resultant force. But whenever this arrow is in the same direction as the other 2 arrows like this means that the resultant is actually equal to 0. So we need to look for a condition where all these arrows are pointing in a chronological manner. So we can see this. So let's see option A. So option A, T forcing like this, W and R. So this actually directly matches our condition we have mentioned earlier. So A is the correct response. So if you look at the other figures, see, they're all showing a resultant in all these other figures. So except for A, all the other figures have a resultant. So as a result, they are not our response. So A is the correct answer. Okay, let's go to the next question. It says a car begins to move. It speeds up until it reaches a constant speed. It continues to travel at this constant speed for the rest of this journey. What happens to the acceleration and what happens to velocity of the car during this journey? Okay, so the question actually asks what happens to the acceleration and what happens to the velocity of the car during the journey. So the first part is very important. It says the car actually begins to move. That means that initial velocity may be 0. So it speeds up until it reaches a constant speed. So it's like this. So it speeds up, that means it accelerates, and then it reaches a constant speed. If you draw a graph of this, then it continues to travel at this constant speed for the rest of the journey. Okay, now it says what happens to the acceleration, what happens to the velocity of the car during this journey. So at this position, if we see, at this particular position where it reaches a constant speed, this acceleration actually becomes constant. So this acceleration, it's at first accelerating and then it reaches a constant acceleration. This means that there is a change in acceleration. Also, we can see that there is also a change in velocity. For example, if this is a VT graph, so this is an increase in velocity and then there is a constant velocity. So since there is an increasing pace of velocity, this means that the velocity is also changing. So if you look at option A, it says both acceleration and velocity changes. So that's the only option we need to go for, because both these quantities, acceleration and velocity, is changing, as you can see in this graph and as they have already mentioned in this question. Okay, the next options are not applicable since it only mentions only acceleration, only velocity, so these are not our choices. Next it says neither acceleration nor velocity changes. That's completely wrong. So A is our correct response. Okay, let's go to the third question. So let's remove that part because we no longer need it. The third question says a speed time graph shows a car's for a car's journey is shown. During which part of the journey is a car moving with a non-uniform acceleration? So it mentions a non-uniform acceleration. We can see that this is actually a speed time graph. So whenever there is a non-uniform acceleration, the gradient will be a carved up gradient. This means that a straight line represents a constant acceleration. This horizontal line with this axis actually represents a constant speed. Only here we can see a curve, which means that it is actually accelerating because of the gradient, increase in gradient. Okay, so C is the correct response here. That's pretty simple. If you know about the graphs, then we should know this. And this D actually represents a constant deceleration, which is not our case. So C is a correct response. Okay, so C will be our response. Okay, next question number 4. It says a car is traveling forwards at a high speed. The brakes are then applied and the car skids along the road surface. In which direction and where does the friction force act? Okay, so this is very important since all these options, as you can see, actually mentions the tires. So we need to understand a key concept of these tires. So as a car is traveling forward at high speed, so if you consider this is our tire and this is the road surface. Okay, so the tire is actually rotating like this. Okay, and this road is actually applying a force to stop the car, which is a frictional force. Okay, so it says the brakes are applied and the car skids along the road surface. Okay, so the driver has applied the brake and it starts skidding. And which direction does its frictional force act? So whenever it's starting to slow down, this friction will always work in such a way so that it wants to actually stop the motion of the car. So the friction always acts backwards on this tire. Okay, so A is the correct response here. Okay, let's go to the next question. Question number 4. The car of mass 800 kilograms has a forward acceleration of 2.5 meter per second square. The frictional force is 1200 newtons, opposes the motion of the car. What is the driving force of the engine of the car? So we already know that F equals ma, so it just represents us for the driving force of the engine of the car. So 800 times 2.5, that's basically it. So if we multiply 800 times 2.5, that's going to give us 2000 newtons. Okay, now it says the driving force of the car due to the engine of the car. Okay, so as I say, so this is not done here, so we need to make another important thing. See, they have also said that the frictional force is 1200 newton. So this force which you find by this equation, F equals to ma, gives us the resultant. Okay, so this force which we get from this equation is the resultant force. So this resultant force need to be added to this 1200 newtons because it need to overcome this force. Okay, so 2000 plus 1200 we need to add, which gives us 3200 newtons, which is D for our answer. So once again, why are we adding this 1200 newton force? Because we are getting this resultant force. This means that 2000 newton is acting completely in the forward direction. Okay, that means by 2000 newton force it's pulling forward, but there was a total of 32,000 newtons and this 1200 newton is actually a backward force. So total 3200 minus 1200 gives us this 2000, which is our resultant in the forward direction. But we are not just looking for the resultant in the forward direction, we are looking for the net or the total force in the forward direction. So we need to add this 1200 because it needs to overcome this 1200. So by adding this 1200 we get 3200 newtons. Okay, now let's go to question number 6. So question number 6 says that a satellite orbits around a planet in circular path as shown. It has a constant speed. There is a force on the planet due to the satellite. Which direction is the force on the planet? Okay, it says in which direction is the force on the planet. Okay, it says that there is a force on the planet due to the satellite. Okay, between two bodies, whenever any force acts between two bodies, this force is actually the gravitational force. Okay, now it just asks us to identify the direction of this force, which we can see is B. Okay, because only B is actually pointing toward the satellite. All these other forces, this is just around the orbit, so the orbit and the planet is not experiencing any force. Okay, it shows the direction of the movement, so this is the direction in which it moves. Since the satellite is located at this position at this time, so this will be the direction of the arrow, because it's between the satellite and this planet. Okay, so that's a gravitational force. Let's look at question number 7. It says a block is hung on a spring balance. The marker inside the balance is pulled down by the block. So this is the block, so this marker is pulled down by the help of the block. So it says what can be the position of the marker used to determine. Okay, so since it's pulled down by the block, so we can just understand it's actually measuring the mass of the block. Since it moves down, this is determining the mass of the block. So the mass, the unit of mass is in kilograms. Okay, so A is the correct response. So why the other response is wrong? It says the mass of the block in newtons. The unit of mass is not newton. The moment caused by the block, no, it's not measuring the moment. It says the weight of the block in kilograms, it shall be in newtons, so that's also wrong. Okay, only the first answer gives us the proper units and the proper quantity. Okay, so that's one thing we need to match when we are confused in these kind of questions, whether it's a mass or the weight. Okay, next question. It says there is an astronaut on a planet that has a gravitational field strength 1/5 of the value of Earth. Okay, so by 1/5 means 1/5 of 10, which is just 2. Okay, then it says he hangs sample of rocks from a spring balance designed to use on Earth. Each sample has a mass of 0.1 kilograms. So mass stays constant in any planet, only the weight changes. That's something we need to understand. The spring balance reads 1 kg. How many samples of rocks are there? Okay, so it says it measures 1 kilograms. So how many rocks can be there? So that's basically 1 divided by 0.1. So this gives us 10. Now what happens at this point is that many candidates actually choose the answer B over here, but we need to consider another thing. Initially there was an information which was given is that it has a gravitational field strength 1/5 of that of Earth, so it shall be able to have 5 times more the amount of rocks, so it's actually 50. So to actually understand the depth of this question, we need to understand one thing. So whenever a spring balance is set up on the moon, for example like this or whatever, so spring balance actually pulls the object. Okay, and this pulling effect, this hanging, whenever the object is actually hung on a spring balance, since it's designed on Earth's gravitational field, it is actually affected by the force of gravity, okay, which is actually weight. So if the gravitational field strength is less, there will be a less pulling by the object. So less pulling will mean that we actually get a less force. Okay, less pulling means we get a less value of the mass or weight, whatever is being measured. Okay, because of the less pull of gravity. So that's how the device or the spring balance actually operates. That's the main operating function of the spring balance. So since there is a less gravitational field strength, there will be less pulling per unit mass in this planet. Okay, so because there is a less pulling of mass, it will show a less mass for a heavier object. So how much less mass will it show? It will show 1/5 less mass. So we need to actually multiply by 5 to our final result to actually get to our proper answer in this question. This is actually a very tricky question, and many people actually make mistake in this question when they first encounter it by thinking that it's just a basic question the other information is useless. So one thing we need to understand and keep in mind while doing these questions is that you always need to ensure or make sure of the special or extra information which they sometimes provide in the question. For example, for this question it was this one, which was 1/5 of the mass of Earth. For the other question, for example, in the frictional question, there was a frictional force of 1200 newtons. So many students actually fail to use these values in their calculation, for which they often get the answer wrong. If they're completely unnecessary, then you can ignore them, but in certain cases and in case of many of the questions, they will be necessary. So you need to make use of this information. You need to think why those information are provided when they are not required. Okay, and then if it's actually, then you need to understand if that has any relation with the question. If it does, then you have to, that will make a difference in your marks, and that can actually prove for you guys to actually get an A star or a world highest or country highest marks in these papers. Okay, let's see question number 9. It says an electrically charged plastic ball is at rest. Which type of field are caused by this ball? Okay, so it says electrically charged plastic ball. Okay, so of course that means it has an electric field associated with it. So which type of field are caused by the ball? And another field which always exists is actually the gravitational field, because it's attracted by gravity and it actually attracts any other masses, because that's a basic thing of gravity. So gravitational field is always usually present. So B is the correct response. Here there is no relation with magnetic field, because other options also say magnetic. It's just electrically charged. It's not actually showing any electromagnetic or just magnetic properties. It's just an electrically charged plastic ball. In static electricity we learned about these things. Okay, and gravitational field is always there. Since there is no option just electric field or just gravitational field, so B is the correct response. The both are present usually. Okay, let's see the next question. Which list contains only quantities that can be changed by a force? Okay, this is a very interesting question. So the thing is, mass cannot be really changed by a force. Okay, so these options are already wrong or already eliminated. We know the shape can be changed by a force. Whenever we apply a force, the velocity can be changed. The volume can also be changed by a force. Okay, so D is the correct response here. So the next question, question number 11, is relatively simple. This is a very common question which comes in the test. So it says which point marks the limit of proportionality for the spring. So whenever the line actually is no longer linear, that's the point where it has reached the limit of proportionality. So now if we notice over here, so just after the point B, it starts to curve a little. So this is actually a curved portion. So after point B, it starts to curve. So that's the point of proportionality. That's B in this question. Okay, that's in question number 12. The diagram shows a diver 20 meters below the surface of a lake. The total pressure in the depth is 3 times 10 to the power 5 pascals. The air bubble of volume 0.60 cm cube leaves the diver. It rises to the surface of the lake with a pressure where the pressure is 1 times 10 to the power 5 pascal. The temperature of air in the bubble remains constant. Okay, constant temperature. What is the volume of air bubble at the surface of this lake? Okay, now so this question is relatively easy. So you just have to use the formula V1 equals to P2 V2. So the pressure at this depth is 3 times 10 to the power 5, and the volume is 0.6 of the bubble at this depth, and the pressure at the top is 1 times 10 to the power 5. We need to find this volume. So if we put these things change the side and put this in a calculator, you'll get 1.8 cm cube, so which is C. Okay, next question number 13. It says the ball is dropped from a height as shown. Ignoring the effects of air resistance, which statement about the total energy of the ball is correct? So it says the total energy of the ball. So ignoring the effects of air resistance, so that's a very important thing. So these are the 3 points which they have mentioned. Since there is no resistance of the air, so because there is no air resistance in this, context, so no energy is actually lost from this ball. So this energy at all these positions, since it has not hit the ground yet, the energy levels at all these places where the ball travels will remain the same, because there is no opposing force acting on the ball. Okay, so energy is being converted, of course there is a highest GP is being converted into kinetic energy, but the net energy that is present within the ball does not change, because it does not hit any surface. Okay, it's not lost to the air around it, or lost to the ground, or lost to any other thing. It stays intact within the ball because there is no other opposing force acting on the ball. So A is the correct response. Okay, number 14, it says a student uses the average force F to push a box with a distance d across a horizontal table. The mass of the box is m and the gravitational field strength is g. How is the work done by the student pushing the box calculated? Okay, so it says pushing the box. So work done, we already know the formula of work done. Work done is force into distance moved in the direction of the force. So it says force is given by A and push a distance d across the horizontal table. So that's the distance moved in direction of the force, which is given by A. We do not have to take d in this consideration, g in this consideration here. So A is the correct response. Very easy. So it says question number 15. It says a workman rolls a barrel of weight 2000 newtons up a plank of length 2 meter onto a lorry. The back of the lorry is 0.8 meters above the horizontal surface of the road. What is the work done of the barrel against gravity? So work done against gravity stands for gravitational potential energy. As we know, work done and energy is interchangeable. So since it says against gravity, so we need to consider GPE. So whenever you see the word against gravity, you automatically consider GPE. That's a trick for all of us. Okay, so what is the mass? So let's see. So they already has given the weight, which is 2000 newtons, so which is basically mg. So where is about 2000 newton upper plank 2 meters high, 2 meters into a lorry. So it's moving 2 meters, but the height we need to consider. That's the important thing over here. So 0.8, so 2000 times 0.8 will give us 1600 joules. So B is the correct response here. Okay. Next question, it says what is power? Okay, basic preliminary definition. So power is, as you know, so the formula of power is actually energy per unit time. So it says force per second, that's wrong. Then it says the maximum force of object exerted, that's wrong. The total energy of the object, energy per second it shall be. So it says work done per second. Work done and energy are same, so energy can also be written as work done by time, and the unit of time is seconds. So D is the correct response. Easy. Question number 17, it says the diagram shows a glass tube filled with water and suspended above a bench. The water is free to circulate around the tube. At point P there is a convection current moving in the downward direction. So this is the point P and this is the direction of conventional current in the downward direction. Then it says at which point is the tube heated to cause this conventional current. So this is a very important thing which we shall all know. So whenever the warm air actually has a lower density and it rises, and the cold air or cold water, whatever, actually sinks because the cold air or water has a higher density. So it says at which point was a convectional current created. So it shall be, since warm actually rises and cold sinks, so this is where the conventional current is actually created. Okay, this is where the conventional current creates. This is the warm water which actually rises up and then again moves down. The cold, it becomes colder and then moves down. So this is where conventional current continues. So it's located here. Okay, so another important thing, some people might get confused, why is it not D? It's because we need to see the direction of the arrow. If this was D, if this is where it was heated, it will move up like this and this would have been the direction. Since it is moving like this in this rotation, which is a clockwise rotation, so it need to rise from A and it drops at this P, so D shall not be the place. So A shall be the place, because if it's heated there, only then it will rise up like this and the conventional current will be this clockwise direction. So that's another confusion cleared out. Okay, question number 18. It says which physical property cannot be used for the measurement of temperature. Okay, so there were certain physical properties which we learn about, in which the temperature that changes directly with temperature. So let's see which one cannot be used. So the length of a metal bar, that can be actually used because that will expand. The mass of a plastic block, cannot be used. That doesn't even make any sense. B is the correct response. All the other pressure and resistance can be used. Okay, question number 19. It says a student performs an experiment to find out how much energy is needed to change the temperature of steel in by 1 degree Celsius. What quantity is a student determining? So energy, so Q equals C equals to Q by del theta. This is the formula for the heat capacity. So the student is actually measuring the heat capacity here, which is A. So heat capacity of the nail. So if you know the formula, so we shall know also that. So that's how heat capacity is defined. Then question number 20, it says a substance has a melting point of minus 17 degrees Celsius, boiling point 117 degrees Celsius. At which state does the substance exist at minus 10 degrees Celsius? So that's between these two ranges. So at minus 17 it actually melts, and at 170 it actually boils. So in between these two states it shall be liquid at minus 10 degrees Celsius. So liquid C and D. Okay, and then 110 degrees Celsius, it's also between this range, so it shall also stay a liquid at 110. So C is the correct response.